Let's take a few moments to practice working with negative exponents and tie the negative exponents together with our exponent rules. Here are a few questions that would help you to ensure that you understand this concept. Pause the video, copy the questions down, give them a try. Check back when you're ready to check your answers. Let's take a look at question A. 6 to the negative 2 times 6 to the negative 3. The first really important idea here is that we have two powers that have the same base. By all means, I could go ahead and evaluate each of the two separate powers and then multiply them together. The most efficient way, however, is to use our power rules and combine them into a single power. Often you're going to find on assessments that I am going to say rewrite as a single power and then evaluate. So that's what we're going to do here. So when we are multiplying two powers that have the same base, we add the exponents. So we could rewrite this as 6 to the negative 2 plus 3, which is 6 to the 1, which of course is the exact same thing as 6. Question B, we're going to notice that we are adding the two powers. So we're not going to be able to apply our power rule for multiplication or for division. Instead, it looks like we're going to have to evaluate each of the two powers and then combine them. What we'll notice is that we have some negative exponents. I want to rewrite that power so that the exponent is no longer a negative. What we will recall from our last lesson is that we can rewrite it as the reciprocal of the base, then with a positive exponent. So notice I could write this as 1 over. Now when I write my power in the denominator, it's only the exponent sign that is going to change. Notice the base is negative 2, that's not going to change, but it's the exponent that's going to become a positive 4 instead of a negative 4. Similarly, for 4 to the exponent negative 2, I'm going to rewrite that as 1 over 4 to the positive 2. Now that I have things written using positive exponents, I can go ahead and evaluate. Our first fraction, 1 is my numerator. My denominator I will determine by multiplying negative 2 by itself 4 times. So negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. So this is going to be 1 over 16. My second fraction, 4 squared is 4 times 4, which is 16. And now I can combine my fractions. You'll notice that the denominator is common for both of those. It's the same, so I don't need to do any more work in that respect. I can simply keep the denominator as it is and add my numerators. So I'm going to end up with 2 over 16. I notice that both my numerator and denominator can be divided by the same value. I could divide both by 2, and so this fraction can be simplified as 1 over 8. Let's take a look at the next question. The last one we'll try together here. I notice that I have division. I also notice that my powers have the same base. Both of these indicate to me that I can do a little bit of work before I start evaluating. For the first power, I have a power of a power, so those two exponents are separated by that bracket. Thinking back to our rules for power of a power, I know that I can multiply my exponents. So that can become 4, negative 2 times negative 3 is going to be equal to 6. I'm going to have divided by 4 to the negative 8. Now, I can make several different pathways forward from here. I think, though, that most of you will recognize that we have division, and when we're dividing powers with the same base, we subtract our exponents. So I will take that path forward just because I think that most of us will probably choose this as well. When I'm dividing two powers with the same base, I subtract exponents. So this will become 6 subtract, And that second exponent is -8, so I need to remember that I'm subtracting a -8. If I'm subtracting a negative, I change that to plus a positive because it's like taking away a debt. So I'll have 6 plus 8 is 14. I could leave this as a power like this. I could also go ahead and evaluate that. I would need my calculator to do that. And I think that is 268,435,456, although I suppose I should check that again just to make sure. Hope this helps you to check your understanding relating to negative exponents. Have a great day, everyone.